Now I would like to hand the floor to our next speaker, Nikita Klimov from MTS. Nikita, welcome. Hi everyone. Hi everyone. My name is Nikita and I am an architect in the AI Center of MTS Telecom Operator. I do different projects. One of the projects that I make is ASR. I will tell about our adventures with automatic speech recognition, talk about what we have been doing, and also describe our pipeline for speech recognition optimization. Let's begin with the data. So, in Russian segment of internet, the biggest data set out there is open speech to text. The most significant problem there is legal clearance. It's cool that there's a huge data set, but it's not clear whether that data can be used in production due to privacy limitations. So, out of the 20 hours of data there, 17,000 of data is the data that has been collected via auto mapping or auto alignment. So, if we use that data for teaching our model, we just learn to work just as the ASR that was used to collect that data. So it's kind of a replication of machine learning model. And the data has been written with auto alignment, and there are different issues there. A colleague of mine was teaching the model, and it has been giving a phrase, the editor is tough, again and again. The editor is tough. It was just generating the phrase, the editor is tough. And we have noticed that in this text that was generated from the speech has this phrase, the editor is tough in the end. So we needed to clean data from this sort of interferences. That's a different sort of adventure, because we don't understand where data is here, how you collect the data, how to map the data, and how to evaluate the quality of mapping. If there's this sort of expertise in your company, probably the best approach to use is to collect your very own data. For generic model, you need about 500 hours. And for fine-tuning for a particular domain, you need another 200 hours. So in the end, you will have no problems with legal issues. In addition, that data will be fine-tuned to your particular task. I would recommend this sort of approach. Next, when there is data, there's a question. How can we use that data to teach the model, to train the model? What can we do? First of all, we need to process the text. First is predictable for characters. Second one is to predictable BPEs. What sort of observations we have here? The BPE grids and BPEs that are taught with the phonemes, they coincide, they come together faster in our experience, but they replicate semantic characteristics, and it's very hard to tune them in the future. That's why character-based approach is better. As for augmentation, it very much depends on the acoustic characteristics. In our case, it was better for masking of certain bins, and quality perturbation. As for content, in our practice, so far it's not working that good. Maybe the content will work better, but so far it does not work as well as spectrographic data. As for the models, for ASRs, they use all sorts of models. Self-attention grids, time depth, deep speech. Here's in the slide what we have tried, and the criteria based on which we evaluated these solutions. The quality is calculated in parrots, because data set for debris speech Clint, we get 2% fear. In production, we will not get a quality that corresponds to debris speech. The acoustic characteristics will always come in a way. That is why I produced the quality in parrots that we got from our data. This on GitHub, there are lots of different implementations, but it's not clear which one can support them. That's an issue. As for implementations, by the deep speech and Facebook WAP2 ladder convolutions. Well, I'll talk briefly. We tried Jasper. Quality is pretty sufficient, and it's a part of NVIDIA framework. NVIDIA has this framework for ThunderFlow. The only disadvantage for Jasper that we've noticed is the number of parameters. It's a heavy workload network. We tried it as one of the candidates. Facebook recently released an exciting framework to teach networks, to train networks, and it allows getting decent quality. But it's all written on Plus, and experimenting is quite inconvenient there and unusual. Deep speech doesn't have implementation, but it's an interesting network with a number of parameters that shows exciting results. Facebook time depth separable convolutions and multi-stream self-attention from SAPP. We have not tried them, but they look promising. Maybe we'll try them, specifically multi-stream self-attention. And something that we selected, NVIDIA Quartz, packet-based network. Again, it's using separable convolutions, and it shows decent quality, and the model itself is not that big. As for optimization of inference, speaking about inference optimization, many often suggest just to quantize it all, and there will be no problem. But blanket quantizing is pretty complex in my opinion, and it's not as easy as it sounds. For example, it was we trained the network on 32, we're quanting it in int 8. So if we do that after training, we'll lose the quality. If we're trying to... Again, it's not easy, because the function will be uninferenceable, and you will have to think about workarounds, and you'll need to write code for message-based quantization, which again slows down the generation of results. In my opinion, we can use simple techniques that improve performance. First and foremost, dynamic batching that allows to get the order right away. In production, when there are many clients in production, there's a problem of memory fragmentation. If you look at the benchmarks, then it's becoming a serious problem. That is why this simple thing like pre-allocation of a section of memory gives the improvement of productivity. Mixed precision training is something that almost every framework supports today, and FP16 inference also gives FP16 infer provides boost for productivity, and ASIC middleware is another important point.
Вот на кварце конкретно еще можно использовать оптимизации под конкретную карточку. Ну, если там, например, у вас вроде V100 либо T4, там можно взять тензор RT, и небольшой, но где-то процентов 5-7 буста он дает. Про инфраструктуру. Самое, наверное, интересное.
So, a few words about infrastructure. Of course, we want to deploy it as quickly as possible. And I often see approaches when the model simply is deployed in Atlas, then it's packed into Docker, and it works in production. This is convenient for an engineer. This is convenient for those who do infrastructure supervision for DevOps. This is a fine approach for those who write business logics. But if we take a look at this as a solution as a whole, this is not a perfect approach. We realize that we need, for example, A/B testing. We need canary deployment or A/B testing to see whether our new model works fine. We need horizontal scaling. We need to have some sort of unified points for logging major metrics. We need easy deployment, monitoring. Preferably, we should have standardized single API so those who write business logics could avoid reinventing the bicycle every single day, and instead that would use some single library. Often we need to ensemble models in the pipeline, different models, and make that using simple Dockers. That's not always perfect, and data transition between Dockers often becomes a bottleneck. We looked at this thing. We looked at the servers that we have today, and we selected this scheme. We preferred this scheme, which allows deploying models quickly. It supports inferences almost in any contemporary format, IMX, ThunderFlow, and others. So the engineers don't need to put any extra effort. They can just push the model in a new repository, and infrastructure can apply that model.
You can simply extend it. SR pipeline processing is very important as post-processing. You can simply write custom backup, which is going to do this work. You can simply unite models through logical pipeline, and data will be transferred from one to another. In order to make this work and be resistant from one side and simple from the other side, we need to have additional conditions. This condition can be Kubernetes or Kef server. This is also very simple. The model is laying in a repository. Model repository is compatible. It has to be tuned up. We say that this is where the model is located. We deploy YAML file, and then it works. Then we have endpoints, where from simple monitoring, logs are being analyzed. And people who write business applications, they have life hacks through which they can connect the library without inventing new integrational solutions every time. This is the end of my presentation. Thank you very much for your attention.
Спасибо большое, Никита, вы
Thank you very much. You gave us even some extra time for questions. Unfortunately, I don't see a lot of questions in the chat, so I will ask a question for myself. What do you think? Which language model should be used better for posing? We have tried different models. We've used Facebook model. We have used KNLM, simple approach, but we didn't see a big boost. So you can use KNLM pipeline, NLM pipeline, plus as an additional stack for corrections of errors, you can use transformer, which has been learned on presets. So from one side you have transcribing, and ML models on the other.